Hello everyone, I'm Xiao Yufang. This is my final project for data mining. First, let me introduce my data set. It's about mountain rescue incident in Taiwan, collected by local fire department. The data covers 5 years, from 2019 to 2024, with a total of 3,476 records and 30 variables. Next, I explain the meaning of each variable in table. If the variable name has 1 star, it's a category variable. If there is no star, it's a numerical variable. 2 star means it's a date. There are 30 category variables in total. This slide shows which variables have missing value. Later, I will explain how I handle them. Here, I list why I remove some variables. First, some have too many missing values, so I delete them. Second, some variables like mountain names or road names had too many unique values and were not useful for analysis. Third, some people-related variables have over 80% zeros, meaning there were usually no one involved, so I removed those two. Then I create some new variables. The first is rescue time in minutes. I calculated it from the rescue time and the reporting time. Then I create a variable called rescued. I combine the original rescue, health, death, and missing. If someone was rescued or had health data, they are considered rescued. If marked as dead or missing, they are not rescued. This became my target variable. Because the region variable had too many categories, I grouped them into North, Central, South, and East. I also grouped Eastern curves into 7 major types. For missing data, since the dataset is large enough, I simply dropped rows with missing values. In the end, I had 2,936 records and 11 variables. For the decision tree model, I didn't do discretization because the accuracy was already good without it. For category variable with loss order, I use one-hot encoding. For loss with order, I use label encoding. Only the year variable use label encoding. I split the data into 80% training and 20% testing. Then I use a loop to test different parameter settings. The best parameters and their accuracy are shown in the picture on the right. I also use Kavan and 4 variable method to select features. The selected features were the same, so I used 5 of them to train the decision tree. After comparing with the 4-variable tree, the model used all variables with entropy gave the best test accuracy. So I used that model for 5-fold cross-validation. The results are shown on the right. From the decision tree graph, we can see that if the number of fire protection units is more than 6.5 and rescue time is over 48 hours, people were not rescued. If rescue time is less than 48 hours and police dispatches are 1.5 or fewer, their people were rescued. Its association rule. I first turn categorical variable into one hard format. Then I discretize the numeric variables into Boolean format. For human count variables, I directly converted them into Boolean values. Since my previous models already had high accuracy, I did not need resampling, even though the data was invariant. The first rule says if the accident cause is lost or delayed, and rescue time is between 30 minutes to 1 hour, then we can predict the year and let the person was rescued. The second rule says if the region is north, rescue time is less than 30 minutes, and there was support from nearby units, then the person did not break the law, and there was a responsible local fire unit. The process for SVN is the same as for decision tree, same encoding, same data split, but with added standardization. The target variable was also label encoded. I trained two types of models, linear SVN and SVC. I used logs to test different C value and method. The result showed that using standardization for both linear SVN and SVC gave the same test accuracy. Only SVC without standardization had lower accuracy, so I chose the standardized linear SVN because it showed table result during looping. Unlike SVC, was the result didn't change with different parameters. Next is random forest. The preprocessing and data speed stayed on the same as in the decision tree. I didn't use standardization because random forest doesn't need it. I picked 4 parameters to tune, and the best 2 combinations gave the same highest accuracy. I chose the one with fewer trees because it changed faster. Now, for KNN, it also didn't use discretization, but did use encoding, data splitting, and standardization like SVN. I test both standardized and non-standardized version to find the best case. The version without standardized gave slightly better accuracy, so I chose that one. This is the able chart for K-means. It shows that 7 is the best number of clusters. Cluster 0 is from common mountain accidents. Rescue time is moderate. Most are due to being lost or falling. Most are from within 48 hours, and the cases are under